All right, guys, we're on the back side of day 2 notes, and in number 2, we got a gallon of paint will cover approximately 450 square feet. An artist wants to paint all the outside surfaces of a cube measuring 12 feet on each edge. What is the least number of gallons of paint he must buy to paint the cube? All right, so let's start off with a picture. So a cube is kind of like a box, but all of the surfaces are squares that are the same exact square. So we're going to start off by drawing a square. And then we're going to draw the same exact square, or at least try to, overlapping one corner. And then we're going to connect the corresponding vertices. Okay, and there's our cube. So it says a gallon of paint will cover approximately 450 square feet. And so when they say square feet, remember that that's the same thing as feet squared. And when they talk about square units, they're talking about the area. Okay. An artist wants to paint all the outside surfaces of the cube. Okay, and they measure 12 feet on each edge. So our squares, okay, are 12 by 12 here. All right. What is the least number of gallons of paint he must buy to paint the cube? All right, so he wants to figure out the area of each surface. So the cool thing about this one is that we have 6 surfaces still, just like the box we had in number 1 on the front side of our notes, okay? But what's unique about a cube is that all 6 surfaces are exactly the same shape with the same size, okay? And so this square, if it's 12 by 12, has an area of 144 feet squared. And there's 6 of them. So 144 times 6 is 864 feet squared. Okay, but they're telling me that 1 gallon of paint can only paint or cover 450 square feet. So if you think about the math there, we're definitely going to need more than 1 can, aren't we? All right. If you go ahead and we divide this by 450, it's actually going to tell us exactly how much paint we're going to need. Okay, so 864 divided by 450 is 1.92 gallons of paint. That's exactly how much we need. But you can't go to like Home Depot or Lowe's and say, hey, I need 1.92 gallons of paint. They're going to say, I'm sorry, they only come in whole gallons. And so we're going to go ahead and need 2 gallons. We'll have some left over, but that is how much we're going to have to purchase. Okay. And that's the least number of gallons of paint he needs to buy in order to paint the cube. Okay. All right, volume. Volume, guys, is the amount of space inside a 3-dimensional solid. Okay. For prisms, all we have to do is find the area of the base shape and then multiply it by the height of the prism. So if you think about volume, it's really just a bunch of flat shapes stacked on top of each other to give it a 3rd dimension of height. Okay, and so let's say that we have, I don't know, let's go with 12 of these shapes all stacked on one on top of each other, so therefore the height would be 12. So we always find out what the area of this is, okay? And then we go ahead and we multiply it, let's say, by 12, because there's 12 of them stacked on. Oh, actually, it's not 12, it's 10. I didn't even see that over there. So let's say that there's 10 of them, okay? Because it's already over here. So we're going to be multiplying our area of our figure in A by the height of how many figures are stacked, which they're saying is 10. And so we end up with a volume, okay, of 2,410 units cubed. Okay, and the reason why we're jumping to units cubed, because this is in units squared, and we're multiplying it by 10 units. And so units squared times units is units cubed. And that's where that comes from. Okay. What's nice is that we have a bit of a volume formula over here. Okay. Big B stands for the area of the base shape. All right. And then our height is the height of our solid. Okay. So we have to realize, guys, that this big B kind of has to be brought off to the side, have the area figured out for whatever the base shape is, and then brought back to the volume formula. So I'll show you guys how to do it, okay? So in number 3, it talks about finding the volume of a rectangular prism. Okay. So a rectangular prism is a box. So we're going to go ahead and draw a box. Okay. So we're going to draw a rectangle, draw the same rectangle, and then connect the corresponding vertices. And there is our rectangular prism. Okay? It tells us that we have a length of 12 feet, a width of 5 feet, and a height of 9 feet. Okay? And we're going to find the volume this time. Okay? I'm pretty sure these are the same dimensions they gave us for the box that we were finding the surface areas, but they changed surface area to volume, so we have to make sure that we change what we do. Okay? So volume of any prism, it's on your reference sheet, is big B times H. But this big B needs to be taken off to the side. Okay? Big B is the area of the base. And our base, which is what is on the bottom here, is a rectangle. So this is the area of the rectangle on the bottom. Okay? Area of a rectangle is base times height. And on that rectangle on the bottom, you can see the two dimensions are 12 by 5, which is 60. And now that we have that 60, the 60 comes back and replaces our big B. Okay? And then we multiply it by the height of our prism, which is 9. Okay? And that's going to give us our volume. So it's basically that black rectangle on the bottom has an area of 60, and there's 9 of them stacked. So 60 times 9 of them stacked gives us a volume of 540 feet cubed. Because it's volume, we have to make sure that we have the right units on for our label. Okay, guys. All right, let's take a look at number 4. So it says calculate the volume of the following right prism. So again, because they said volume, they said prism, we know that the volume formula from our reference sheet is big B times H. Okay. However, big B, we have to realize, needs to be taken off to the side, and big B has to be explained as the area of and now a lot of people will say rectangle, and that's not true. Okay. One of two things. This shape here is called a triangular prism. So what it is it's a bunch of triangles stacked upon each other to form this triangular prism. Okay. So in this picture, it's a little deceiving. Okay. But if it's called a triangular prism, prisms are named by their base shape. And so the triangular prism's base shape is a triangle. So our big B is the area of a triangle. So we almost have to kind of stand this triangle up and realize that this triangle right here is actually our base shape. Okay. And since area of a triangular, I should have said area of a triangle. Sorry, guys. Okay. Area of a triangle. Okay. An area of a triangle is 1/2 base times height from our reference sheet. Okay. So we're going to keep the 1/2, and we're going to need to look for the base and the height of our triangle. So in our triangle here, we also have to remember that base and height have to be perpendicular. So this could be my base or my height, and this could be the other. All right. So you're going to have to realize that 10 isn't one of them. However, this is a right triangle, and we're going to go ahead and use our Pythagorean theorem to figure out our missing dimensions. So we'll go ahead and say a squared plus b squared equals c squared. Notice that 10 is across from the right angle, so 10 has to be our hypotenuse, which is our c, and 6 can either go in for a or b. All right. This ends up giving me 36 plus b squared equals 100. And therefore, when we subtract 36, b squared equals 64. We'll take the square root, and b comes out to equal 8. And so this missing dimension here is 8. Okay. And so 6 and 8, doesn't matter which one's which, okay, are going to be our base and our height. So we're going to go ahead and say 1/2 times our base, let's say, is 6, our height, which is 8 of that right triangle. Okay. And again, it might help to take that right triangle and stand him up so that you can see that we have 6 and 8 being our base and our height, and the 10 is not our base or our height. Okay. Remember, base and height have to be perpendicular. They have to have that right angle in between them. All right, so 6 times 8 is 48, and half of that is 24. And so now we're going to take that 24 and go back and put it in for our big B. That is the area of our base. So we have these right triangles, okay, that have an area of 24, all stacked up on top of each other, okay? And there are 15 of them stacked up because there is the height of our prism, which is going to go in for our H here. And we have 24 times 15. And 24 times 15 is going to give us a volume of 360. And our units is meters, and it's going to be cubed because it's volume. And there's the volume of our triangular prism. Okay, so a little complicated, a lot of math. Let's try number 5. You'll get the hang of it. All right, in number 5, we have a right prism with a square base with an area of 12 square meters. They're saying that the volume of the prism is 84 cubic meters, and they want us to determine and state the height of the prism in meters. All right, so let's get a picture. So we have a right prism, which just means it stands straight up and down with a square base. Okay, so we have a square base on the bottom, and it's a prism. So what that means to me is that it's going to have the same square base on top. So if we kind of connect these like this, you can kind of get a nice visual of our square base on top. Same square base on the bottom, which makes this a prism. Okay. And we just don't know how tall it is. Okay. So up on top, it says that the square base on the bottom, okay, has an area of 12 meters squared. Okay. And they're telling us the volume is 84 square meters. And so this is a prism, right? So we're going to go to our reference sheet, write down the formula for volume of a prism, which is big B times H. Okay. And we're going to go ahead and take that volume out because they've told us the volume is 84. Okay. We're also going to take big B out because they told us the area of the base, which is what big B is. And so we're going to replace it with a 12. They already did the side work and figured out that area. Okay. And we just don't know the height of the prism. So we'll just keep this as H. And since we're solving for H and they're connected by multiplication, we're going to divide by 12 so that the 12s cancel and H is now by itself, and 84 divided by 12 is 7. And so that would be 7 meters because height is just in one dimension. It's not a volume. It's not an area. So it's just meters, not meters squared or meters cubed. And that problem's done. All right, I'll see you guys on the next page.